In Algebra 2, Section 3.2, we're dealing with solving systems of equations algebraically. So last section you dealt with solving equations using graphs and how the graphs intersect. Now we can do it without using graphs, which might make some of you guys excited because you're not too fond of graphs, but it's okay. There's two different methods we're going to use, substitution and elimination. Now substitution should only be used in certain cases, whereas elimination is a little bit more work, but you can use it anytime. Alright, so let's do an example of substitution. The best case of using substitution is when you have a coefficient that is 1. Coefficient is the number in front of any letter. So the number in front of any letter, if it's anything big, if all the numbers in front of the letter are bigger than 1, then you should not use substitution. But if you can find at least 1, then substitution would be the best and the easiest way to solve this problem. Okay? So for example, we have two letters here that we're going to be that we can use. We can use this x or this x. See, both of them have no number in front of it, so that means that the number is 1. So I'm going to solve for that specific letter. And when I say solve, what does that mean? It means that I want to isolate that letter, so bring everything else on the other side. So if I have x, okay, so I'm going to take this, okay, x plus 4y equals 26. Alright? So I'm going to solve for it. That means 4y is attached by positive, so I'm going to subtract all of it. So I end up with x equals 26 minus 4y. Alright? Once that happens, then, if you imagine it, it's like these letters, the x and the y's, have to be the same, right? So they have the same solution and we're looking for it. So we have to pretend, like, well, not pretend, but we act as if this is the same thing. So whatever this x is also this x. They're the same thing, even though they're two different equations, because they're a system of equations, so they work together. So that means if this is x and x equals 26 minus 4y, we know that we can do what? We can substitute, just like the term substitution. So I'm going to put this in a little bubble, okay? It's this little cloud bubble, and I'm going to take it and I'm going to take the whole equation and replace the x. Okay, one more time. I'm going to take this whole equation and replace the x. If this was y, then I would take this whole equation and replace it with y, and then I would distribute the negative 5. But this doesn't have a number in front of it. So I'm going to take it, and now I end up with 26 minus 4y. So this thing is my x. Everything else stays the same. Negative 5y equals negative 10. Okay, so what I did is this was my x. I erased the x and I substituted for this bubble. Once I'm able to do that, then I can just combine like terms and solve. So 26 has no like terms, so I'm going to bring that down. So negative 4y minus 5y gives me negative 9y equals negative 10. And from there, it's just algebra. I'm going to subtract 26 from both sides. I end up with negative 9y equals negative 36. Then I divide by negative 9, divide by negative 9. This gives me y. This negative and negative cancel out, and I get y equals 4. Well, I'm not going to actually circle it yet because that's not my final answer. So I know what y is. Now, I need to find out what x is. I know, and now since I have a y, I can plug it in either one of these. And I can solve for x. Because remember, you can only solve an equation when there's a maximum of how many variables? Just one. Okay? So we couldn't solve these because both of them had a missing x and a missing y. But if we solve one for x, we substitute it in, and now this equation only has one letter, which is y. And once we find y, now we can plug it into any of these. It doesn't matter which one because they have to be the same. We can plug it to any of these, and I should get my x. Okay, and because the x has to be the same, then it should be the same for both. So if I choose the first one, x plus 4y equals 26. X, we don't know. 4 times y, which is 4, equals 26. So x plus 16 equals 26. And then I do what? My last step is to subtract 16 from both sides. I end up with x equals 10. So my final answer is x comma y, which is 10 comma 4. What does this mean? That means if I graph these two lines, they're going to intersect at 10 comma 4. That's the point that they both share. So go ahead and write this down. This is essentially my first step. Okay, then I put this in. This is my second step, and the purple is my third step. So go ahead and write this down, do your vocabulary, and turn to page 127 and do number 2. Page 127, do number 2. And this is asking you to do substitution. Our second and last step is elimination. Now elimination can be used anytime. It's a little bit more work for substitution, so if you could do substitution, that would be best. But sometimes you can't always use substitution, and because all of the letters have everything bigger than 1. So use this process of elimination, and we're doing just like what the name is asking us to do. We're trying to eliminate 1. Now, our rule when it comes to equations is that I can do whatever I want to the equation, as long as whatever I do it on both sides of the equal sign to keep it balanced. Okay? So in this case, I have 2x and 5x. If I subtracted that, I would get negative 3x. What I want to do is I ultimately want to choose one where when I subtract it, okay, it will give me a 0. Well, first let's find a common. For example, let's look at x. Okay? X has 2x and 5x. Now, what number do they both have in common? They both can go into what? 10. Right? Let's use 10 as an imaginary. They also can both go into 20. They both can go into 30. So it doesn't matter which number, but I'm going to try to choose the smallest number, which 5 goes into 10 and 2 goes into 10. So I want to see how to change it. So in order for me to turn 2 into a 10, I have to multiply it by 5, right? 5 times 2 is 10. So I want to multiply this entire equation by 5. So 5 times 2 equals 10x. Now as long as I do it to everything, it's fine. So 5 times 3 is positive 15y. Okay, and then 5 times 4, 5 times 12 is 60, yes, equals 60, alright? Now on this one, in order for me to turn 5 into my magic number, which is 10, I have to multiply it by 2. So I multiply the whole thing by 2. So 5 times 2 is 10, okay? Negative 2 times 2 is negative 4y, and then 11 times 2 is 22. So one more time, what I wanted to do is I wanted both of these numbers to be the same, okay? And in order for me to do that, I had to multiply this by a number and this by a number, which now when I look at it, I have 10x and 10x. What that means is now I can eliminate. Once you have it the same, then I can just subtract. 10x minus 10x is 0, so they cancel out. That's my goal. I want to try to eliminate. So I eliminated the x by making them the same. And that was the whole point of me multiplying that. I wanted to make it the same. So after that, then I just do the rest. 15x minus a negative would be a positive. So 15y minus a negative, so 15y plus 4 gives me 19y. Okay? And 60 minus 22, pull out my calculator because it's a long day. So 60 minus 22 gives us 38. And I divide both sides by 19. This cancels out, and I end up with y equals 2. So let's recap one more time. I want to eliminate a letter, so I multiply this whole equation by the same number. It has to be the same number, and this whole equation by another number, so that I can get them the same. Now I don't have to multiply them by the same number both, but I have to multiply everything across by the same number. Okay? Once that's done, I'm going to eliminate, and then I'm just going to solve, because now that I eliminated this, I have how many variables? 1. And because I have one variable, now I can solve, and I just divide both sides by 19, it gives me y equals 2. Now what do? Well, now that I have a y, I can plug in y in either of the equations, right? It doesn't matter. I can plug in y in either of the equations. Once I plug in y, then I only have how many more variables? 1. I'll just have x, and then I can solve. So once I get to here, I'm home free. So if I have, I'm going to take the first one because it's easier. 2x plus 3y equals 12. Okay, I chose the first equation, and I'm going to replace y now with 2. So 2x plus 3 times 2 equals 12. Now how many variables? I have 1, just x, so I'm going to solve. So 2x plus 6 equals 12, right? 3 times 2 is 12. And then I'm going to subtract 6 on both sides. I end up with 2x equals 6. And my final step is to do what? Is to divide both sides by 2. I end up with x equals 3. So my answer is x comma y, which is 3 comma 2. Right? And that's elimination. So substitute, we're actually putting things, we're solving for a letter, and then we're going to replace it. We're going to substitute it. Elimination is actually eliminating a letter. Now elimination I can use anytime I want. Substitution, on the other hand, I can only use it when I have one variable. Okay? I'm sorry, when I have a variable with the number 1 in front of it. So go ahead and do this, write this one down, and then do page 127, number 8. So the first problem, you're going to do 127, number 2. This one is 127, number 8. And I will see you tomorrow.